And you can start whenever you want. I assume people will just log on.
Sure. Do they need to be admitted or anything?
No, there's they and there will I don't believe there'll be any sound to you, so it won't be disruptive.
Well, no, I just wanted to make sure they weren't in a waiting room.
Yeah. Yeah, no, there's nobody in the waiting room. That's Zoom.
Like I said. All right, well then I will get started. Hello, everyone. I wanted to welcome you to a wonderful panel discussion on robotics education. We have a wide set of panelists here that have expertise in a lot of different areas and different types of teaching scenarios. So I'm really excited to get to share this conversation with you. I do want to remind you that we are recording this so that if you want to look at it later or share with a colleague, you'll have that resource for you. So this will be recorded. If you have questions, we encourage you to put those in the chat. Make sure that you select host and presenter when you put them in the chat so that we can see them. And periodically through the panel, we'll pause and review those in the chat and address your questions. We'd love to hear your feedback and make this as interactive as possible. I also want to thank Amy and Alexis and everyone else at RAS for setting everything up and organizing everything and making this possible. We really appreciate it. So let's get started. We'll introduce our panelists. I'm going to ask them to introduce themselves one by one. I want them to share with you their area of expertise and in particular what robotics related classes they've taught and what modality those were taught in, whether they were in person, online, a hybrid, or something else. So Carlotta, will you get us started?
Absolutely. Good day, everyone. I am Carlotta Berry. I'm a professor of electrical and computer engineering at Rose-Hulman Institute of Technology, which is in Terre Haute, Indiana. No one knows where that is. It's about an hour west of Indianapolis. It's a primarily undergraduate institution, so we don't have PhD students. So I have taught mobile robotics, and I have taught it face-to-face as well as in a flipped format. And that was actually even before the pandemic. It was because of the demand, and there was only one me, so I had to start teaching the class flipped so that I could get more students in the class. I've also taught human-robot interaction. I taught that to graduate students at another university, and those were non-technical students. So those students were in computer science and media arts and science. So that was face-to-face. And my area of expertise is human-robot interaction. But at Rose-Hulman, I actually do more robotics education and engineering education work.
Thank you. Katie, would you like to go next?
Yeah. Hi, everyone. My name is Katie Joyce-Campbell. I'm an assistant professor at the University of Illinois at Urbana-Champaign, and I'm in the electrical and computer engineering department. So my research is in safe interactive robotics. So I pull from safe and robust control and decision-making, as well as human-robot interaction. So I've taught a few classes now. So I've developed a course on safe autonomy that was targeting undergraduates. And that was all in person. And I've also been working on overhauling the Introduction to Robotics class here at Illinois. I taught it last semester, which was by force half online and half in person. And now I'm teaching a graduate special topics class, which is on human-centered robotics.
Thank you. Cecilia? Cecilia, will you introduce yourself? All right, we'll come back. She may be having some technical issues, so we'll come back. All right, Wanda?
Hi, my name is Yolanda Leite. I am an associate professor at the Division of Robotics, Perception and Learning at the School of Electrical Engineering and Computer Science at KTH in Stockholm. My main area of research is human-robot interaction, and I've been teaching in the past couple of years a master level course on artificial intelligence and also a PhD level course on social robotics. The AI course now has mostly went to digital format, so a little bit of flipped classroom, but we have still some in-person labs, for example, but it's mostly in the digital form these days.
Thank you. Karine?
Sure. Yeah, I think Cecilia is back. I don't know if you want to go
Oh.
first.
Yeah, that would be wonderful.
Okay, so sorry, I had a small interruption, my connection, don't know why. I'm a professor. As you see, I'm at the National University of Singapore. I recently joined this university in the mechanical engineering department. But most of my career was in Italy at the Scuola Superiore di Sant'Anna, and I was in the Biorobotics Institute. So my research is in biorobotics, and also my teaching is both in robotics in a more general sense, but also in bio-inspired robotics and soft robotics recently, which is my field of research. So, in this long experience, I, of course, especially had in-person classes, but recently I had to adapt to remote teaching, which was at the end of but still with a perspective of next semester to have classes in person. I usually teach at let's say graduate level, and a number of students in the next semester is expected to be small enough to allow for in-person again. But this remote teaching experience is very important.
We are all getting a crash course in that, I think, if we didn't have that experience already.
Yeah.
All right, Karine, do you want to wrap us up with the introductions?
Yes, thank you. Thank you for the invitation, first of all. Yeah, so my name is Karin Ramirez. I'm an assistant professor here at Chalmers, also in Sweden. My background is in electrical engineering department. My background, so I got a computer science degree, a master's degree also in computer science, and then a PhD in electrical engineering. And this is when I apply AI and robotics together. So my area of expertise is a high-level understanding of human intentions. And this is high-level decision-making under a lot of uncertainty. And because of that, so I developed a new lecture right now. Actually, I had this extreme situation that I'm new to the university, a new teaching system, online system, new lecture, new students. So it's like the whole package. I got the whole grail. So adapting, everything is online, the new teaching, the new material, everything. And so far the students have accepted this course good enough. So actually, this is the first time we teach this lecture here. It's a master course, and so far it's going good, yeah.
Good. I'm sure that was a fire hose to learn from.
Yeah, so we have to get used to all this Zoom, everything. So yeah.
Yeah. Well, I appreciate all of you being here today and taking time out of your busy schedule to talk about robotics education and research in that area, and you know how we're handling this new teaching climate that we're in. So the first thing I would love for us to discuss is to highlight some best practices in robotics education. So these would be teaching practices that you have either seen or done yourself that have been really successful, particularly in a robotics or robotics related course. I would love for our participants to hear about them because so that they could potentially take those practices into their own classrooms and impact their own students, you know, at their institutions. So we'll do this kind of, you know, popcorn style, volunteer up, keep it pretty informal and conversational. So whoever would like to go first.
I did my spirit fingers, so I'll go ahead and go first. I forgot to mention that even though I've taught mobile robotics and human and robot interaction, I also use robotics in some non-robotics courses. So I've taught robotics at the K through 12 level, as well as for our freshman electrical engineering design course. So I wanted to say for best practice is get their hands on something. I know there's this big debate for simulators versus hands-on experience. And for someone who went through undergrad and took robotics classes and never touched a robot, I'm a big proponent of tinkering and hacking and making mistakes with wiring things wrong and seeing things smoke. So no matter how trivial it is, get their hands on something, even if it's just to see a motor spin. And I think there's so much value in that. And I know it can be cost prohibitive, especially now that we're in this virtual environment. But my school has done things like shipping kits to homes and having students ship them back in a self-addressed envelope at the end of the quarter. So just something so that they can get that hands-on experience. That's what's most important.
So I actually agree on that. So I think the best practice is hands-on. It has to be a balance between the theory that you see and the practice they need to do. And for me, that has been a good result. So I always have like the theory, and after the theory, I have a practice session where they actually have to do hands-on. And it's always interesting when they actually see like the camera or something that is happening. For them, it's also, and that's the feedback we usually get. They say, yeah, it's a lot of work because they need to learn a lot of things, programming and a lot of things. But at the end of the day, I think they appreciate when they see hands-on experience.
So how do you suggest, if someone's developing a new course or trying to revamp an existing course, how do you suggest that they go and inject these kinds of hands-on experiences? You know, what strategies should they use? How should they worry about, funding and resources? And then, you also mentioned shipping kits around if necessary. So what, imagine someone's, sitting and looking at the course and say, I would love to give an experience. How would you suggest they go about starting out? Because that can feel a little overwhelming if you have a course that doesn't already do that.
Maybe I can add something here. Okay, I just agree with previous experiences about hands-on. It's definitely fundamental, especially for robotics, because robotics is physical, it's something that you have to see. And I must say that if I compare when I started years ago, I see that today there are many more tools for doing hands-on classes, and there are robotics kits that were very difficult. I used to teach with the real robots from the lab, and that was not really practical sometimes. So my suggestion is to definitely invest in this part of the course and try the many robotics kits that are available today, and they're very, very helpful. Of course, an experience in a lab is always valuable, even if it's a bit, more difficult. Depends on the number of students and the facilities that the teacher has available. But I would like to point out also another point here. Hands-on is definitely good, but there are other ways to engage the students. Even for the part of I teach, in a class and I give a lecture, I try to first show what I want to explain, then try to challenge them to find the the explanation, to propose their own idea, their own view, even with some fast search on the internet. So if you engage them in forming their own idea, and then after that you discuss and compare, and you finally give the correct explanation and answer, I think that this is more effective in educational terms because of their engagement. And even with remote teaching, such an engagement can help them stay focused and listen more and learn more.
So
If I can add,
go ahead, yes. Yeah.
something on student engagement, especially in these extreme circumstances of remote teaching. One of the things that we learned, the past couple of months is to constantly get student feedback, not wait to the end of the semester or to understand their ideas on how the assignments were and so on. So in addition to the virtual labs, we not just one TA in the labs, for example, where for the same number of students, when we have a physical lab or a virtual lab, we have way more TAs now in the virtual lab to make sure that everyone has the chance to interact a little bit. We have more of these, what we call consultation sessions, pretty much almost every other day, where a TA in the beginning of the day or at the end of the day is just there and you can quickly sign up to get some quick feedback on the projects and so on, to basically to ensure that all these like hands-on experience or they don't get lost, because it's way easier to see in the physical, in the in-person interactions, these type of things, or talk with them after class and so on. And when we move to this like remote teaching, where the little feedback we get is from the Zoom chat and so on, it becomes a bit more challenging for them as well. So at some point in the course, we have a survey, for example, just to assess how things are going with the assignments and so on. So getting constant feedback, I would say, is
I'm sure that's good for any subject, actually, to not wait. I know I've used polls and surveys when we were in person, just even passing out index cards, a very low tech, cheap way. Then I find too that students really appreciate hearing that you want their feedback and then seeing you make a change, because then they feel like their voices, mean something to you, and they're more engaged in the rest of the course. Even if it's a challenging course, they have some buy-in because they feel like they have a say in the process. So that is a wonderful suggestion. And I love also the talk about these kind of active learning techniques, about letting them see something, hypothesize on what they think is going on, explore a little on their own, and then all coming together and sharing, and then showing, like making sure they all have the correct understanding when they walk out, right? When you do techniques like that, do you ever get the feedback that students feel like they're teaching themselves and don't like that? Or are you able to help them understand that this is a really great way to learn?
So I'll take that. So one thing that I have discovered is when the students are passionate about what they're doing, they're a lot more forgiving for that. So for example, I teach controls, I teach signals and systems. Those types of classes, they want you to tell them what's going on. But in my mobile robotics course, they are so excited to be working with the robot that I can give them assignments sometimes where I'm not even sure what the answer is. And they will search the internet for hours to figure out solutions. And then they come and tell me, look what I discovered, look what I made. And sometimes it's something I hadn't thought about. And so that the sum of the parts is so much more than what I gave them. So if it's something that they're passionate about and engaged in, this last time I taught it, right before the pandemic, I gave them an assignment to make a GUI, a human robot interface for localization and mapping. And I only knew one way to do it, which was using processing because they use an Arduino microcontroller. And some of the students were like, no, I want to do it in Java. I want to do it in MATLAB. I want to do it in ROS. I was like, well, I don't know how to do that, but you can do it if you want to. And half the class went and figured out how to do it so they could do it their way. So they don't always complain about it. It's only when they don't have any clue and they're not passionate about the topic.
One thing I found with some of these sort of free-form projects, which I try to incorporate in all of my robotics classes, is that students often, if they feel like there's too much uncertainty, especially for undergraduates, when at the end of the day they are trying to get a grade and they want to do some of these things, sometimes that that sort of lack of structure adds a little bit of stress. So one of the things that I found is allowing students to not have to be successful. So even if their project fails, if they can tell me why it failed and really dive into the challenges and explore those, they will get equal credit for talking about how their robot failed for how their robot completed the task. So I think having some expectations that basically are not just about success, but about, exploration, and having really thorough rubrics a lot. So students basically can sort of self-optimize and I figure out how to spend their time, and it's a little bit more guided, so it kind of decreases some of that stress.
I'm sure that does. When you create rubrics, do you talk them through them and show them how to use them to self-assess, or is it something different?
I don't necessarily walk the students through them, but I try to put examples for at least 2 or 3 of so in the matrix, put examples of what I would expect for the different scores and whatnot. I also try really hard to put not have everyone shoot for like 5 out of 5 on everything, but so if there are 5 topics and you can get 1 to 5 on each, say, okay, you have to collect like 20 points. So they don't have to max out everything, but they should overachieve on some. And if they drop on a little bit, that's okay. Which sometimes is a little bit more confusing for students, but I like this idea that they don't have to max out scores on everything.
Yeah, that allows them to kind of specialize a little bit and make sure they're not just getting breadth, but they're also getting deep into a topic.
So Shauna, I wanted to follow up on what Katie said. I've noticed that the level of the students makes a difference. So my freshmen really, really obsess about their grades. So when they found out they had to get a robot working that had to compete in a competition by the end of the quarter, they were in tears because they didn't want to fail their first class in college. So by taking the grade away and saying the competition is for fun, even if your robot is a paperweight in the middle of the field, you still pass the class. So I had to distinguish by being transparent about how they were graded in order for them to take that anxiety away from the process. It's about the design process, not by whether your robot actually functioned and was able to compete at a high level. And I noticed that people say a lot that women don't like competitions, and it's kind of a turn off when you do robots competitions. But I think when you take some of that out of the equation, the women and men I found in my classes equally had fun.
This is a good segue. I'm watching the chat. We have a lot of great questions about a lot of the things you're talking about here. And one even asked about failing. So talking about hands-on experiences, would you give them a challenge that you kind of expect them to fail? And if so, how do you handle that or use that as a learning moment for them? Or what do you think about that kind of idea of proposing a challenge for them, knowing that it may be outside what they can do, but you're trying to see how far they get?
I never gave on purpose something impossible, but I still think that failing in this kind of hands-on experiences or student projects is the most important part for learning. So it's not just learning how to do something, but seeing how much you can make mistakes. So, for example, that's why it's not so easy to replace this hands-on or this project experiences with something done remotely. For example, with videos, you can think of replacing a class in lab with a video of the to be wrong.
So this isn't.
Go ahead.
Oh, so this isn't maybe directly related to the question. So if anyone has a more direct answer, feel free to interrupt me. But one of the tools that I use for homework is this online platform called PrairieLearn, which is this mastery-driven framework, which is basically you design some homework problem, you put it on, and people put in their answers, and they get immediate feedback. And the questions are often randomized, so they basically can keep working on something until they get it right. And this is really great because, again, that sort of immediate feedback is really important. But one of the downsides for this is if the students don't get it, or if they have a hard time with it, this can be really stressful for them, as they can just see what they are not getting, and they kind of see that they're not getting the 100% on these. So I think with all of these things, if it's a homework assignment where they know they're not going to get full credit, or if there is a project that is challenging and they're maybe not quite getting it, there's a sort of a fine balance that I think needs to be struck in making sure students feel like they are achieving, and it's not, there's not high enough consequences that they'll decide that they don't like this area, don't want to keep pursuing it. So I think balancing that sort of that stress and engagement, I think, is a challenge in general.
So
Yeah.
Shauna, I wanted to follow up Katie as well and say, as an undergraduate student who was frequently frustrated in my electrical and engineering courses, I'm not a big proponent of giving students questions that would frustrate them. I believe in challenging students and scaffolding using like Bloom's taxonomy and making things more difficult, especially as they move through the curriculum and they mature in it. But I don't normally give students something that's impossible because they're still learning and they don't always recognize when they're going down a pathway to an unsolvable problem. And I don't want to frustrate for somebody for 20 hours doing an assignment when I know there's no answer to it. So I think there's a fine line in me challenging you because I'm looking for you to grow in those levels of comprehension and synthesis versus just frustrating you for the sake of it.
That is a good point. You want to make sure you have your pulse on how the student is, responding to the way the class is going, and that you're you want to, is that balance. You want to challenge them, but not exasperate them to where they throw their hands up and walk away, because that's a loss for everyone, I think, when someone says this isn't for me. So that's a really good point to keep in mind. Katie put the link to the platform that she was talking about in the chat if you would like to learn more there. And
I add something very quickly to the discussion.
Yeah.
I think one important thing that we always need to consider is the generations of students. So each generation changes like drastically sometimes. So the first thing we need to do is we need to assess which generation are we dealing with. So they will be able to see the challenge like something positive, or they will see it as something negative, because also this will be reflected later on. Some students tend to have resistance to new concepts or to new interactions from our side. And something that I have seen right now with all this pandemic and the switch, of course, students feel frustrated. And it's the same way for us. We also feel frustrated. We cannot give fully 100% what we are supposed to, right? So, and we just need to find this balance somehow. So the way I find balance is I try to get feedback, and I always inform students. Today I will try something different. Let's see how this works. And we'll try pool and then breakout rooms. And they say, no, maybe breakout rooms, not too much. And so that's how I start, because also I need to get adjusted to the Swedish system now. So I don't really know how this works. So this perhaps could be interesting to someone in moving to a new research or institution, so they can assess. I think the first thing is to assess who you are teaching. Learn from that.
Yeah, I think that's great, your advice to say, hey, I'm trying something new today, because what you're doing also is you're modeling for them that you don't have it all necessarily figured out, and that should not be their expectation that if I don't have it figured out, this is not for me, right? And so you're modeling, hey, I'm trying something new. This may be a raging success. It may be an utter failure, but we're in this together, and I'm looking for your feedback, and we'll, you know, do more or less depending on how it goes. So I think that's really wonderful to be transparent with your students like that. I have one last question for this section, and then we'll move on to talking about some specific challenges. But one question is, someone asked that since you all have a passion for a particular research area, how do you find ways to pass that along to your students or expose them to different ideas in your very specialized topic, and maybe in a more general class?
If I can, I teach AI, which is quite generic, but then I'm passionate about interactive intelligent systems that interact with people, for example. So in essence, what happens is most of the examples, for example, that I use in certain lectures reflect a lot this, or robotics, right? When we talk about planning, then it's always about a robot wanting to go from some place to another place and these kind of things. And by the end of the course, I think that's usually reflected a little bit in the students. I guess we cannot avoid that, but I see it in a good way, because we're giving them examples and concrete state-of-the-art things that we know that might motivate them and that we are passionate about. So when we communicate them why this is important, they see a concrete example, and I think that's in general positive. But I might be biasing a little bit the course towards and my colleagues do the same for their own like different fields. So I guess in the end we're fine.
So one thing that I do, since my class is multidisciplinary and I have students from mechanical engineering, electrical engineering, computer science, and software engineering, their skill sets are kind of all over the place. And I have to get students who can do some research for me out of that class. So every week I have them read a paper on some topic that's state of the art. They are undergrad, so I try to pick some of the lower level ones. Like I might do a Robin Murphy paper on search and rescue robotics, or I'll do a Maya Matarik paper on subsumption architecture, or whatever, but something related to what I'm teaching them, so that by the end of the quarter, I can kind of see who comes to me after class and says, hey, that paper was kind of cool. Ooh, I need you to do some research with me next quarter. So that's kind of how I find my students, by having them, the ones who go above and beyond the assignments I give them and want to continue to engage with the topic.
That's a great recruiting strategy. I'm going to make sure to use that one. So thank you. All right, let's talk about some specific challenges that I know are on a lot of our minds right now, especially when we're teaching in an environment that maybe is not what we're used to. So the first one I want to talk about is, how do you best engage students? And we've talked a little bit about that, and talking about, activating their passions and doing hands-on experiences and things like that. But are there any other, and asking for their feedback, but are there any other strategies that you have found really helpful to engage students, especially the ones that are participating remotely, that may not be right in front of you. I know I have a lot of students that I've actually never met in person because of the way this semester has gone, but I've had a lot of interaction with them online or in Zoom or other ways. So how do you engage your students, especially in this current scenario?
So this summer, we spent this summer basically transferring our intro to robotics lab, which is probably poorly named. It's a senior level course on robotics, but our introduction to robotics class we transferred it. So normally we have a nice lab with UR3s where they come in and interact with the real robots, and we transferred it to simulation. But since we're able to do have students come on campus this semester, what we've tried to do is if the students are signed up for the remote labs and they're doing the simulation, they buddy up with someone who actually comes into the lab and works with the robot, and they can't actually deploy everything that they developed in their gazebo simulation and just transfer it to the real world. And it transfers fairly well with limited changes or interventions. So this buddy system has been something that's fairly nice. And I know here at Illinois, they're doing a similar thing with the controls classes where there aren't as many nice simulations and whatnot. So this sort of buddy system kind of helps ground and engage the students. But I'm excited to hear how other people are handling it. It definitely is a challenge.
Well, I'm sure that has the added benefit of you're getting students to work with each other and learn from each other. And so you're developing a lot of those, they're often called the soft skills, but they're really essential for, teamwork and whether they're going to go into industry or academia long term, we don't ever work in a vacuum. So I can almost see that type of buddy system might be something that would carry forward because of the other benefits it has. That's a great idea. What others to engage students?
So in my case, one particular challenge is we cannot guarantee that all students have the same powerful computer that they will have on a lab, right? And we would talk about robotics, and we have Gazebo and these artists, and then we have ROS, and then we have Linux, and then so you keep piling up that everything is perfectly installed on the lab. But now that they have to do it at home, then we have to be creative. And I was investigating a lot of different platforms. And the one I'm using right now is ROS Development Studio, that is actually like a web computer in the cloud. And students just need to open that, and they don't need to even install anything. So everything is already there. And the cool thing is that there is just a switch. Of course, you have the license. There's a switch that they can actually control the real robot. So they can connect to the real robot. So, and I just find out that last week they released like a lab, a real lab, where students using this tool can actually access and have time with the real robots everywhere where they are. So I think, for me, this is the tool that I'm working in right now. And we just have the laboratory assignment for this last week. And so far it's going, of course, it's a new tool, so it has some things to be improved, but the developer, I'm in contact with him, and he's always trying to fix things on the way, because of course this is everything new for everyone. But so far, I think that's a good solution in this perspective, when we cannot guarantee that every student have the same hardware, a computer home.
So I was going to share that at my school, it's required for all the students to have the same laptop. So I don't have the challenge that Corinne does, because they all have access to the same computer and the same software. But it does get more difficult as they get higher up. So when we went virtual, I was teaching controls. So at that point, we just got rid of the rest of the hardware labs, and everything was MATLAB and Simulink. So that's the great thing, is you can do some stuff that's still rich. I think robotics is not quite as rich in simulation, but if you're teaching controls and they're doing Simulink and making some graphs, a graph's a graph, right? So I think that works okay. But for the lower level courses, some things I've done at that K through 12 and freshman level, they don't have a textbook. And you can get like a Spark Fun Arduino Inventors Kit for about $90, which is about what a college textbook would cost. So if they're all home and they have to get that same kit, the latest version of that actually makes a really rudimentary robot at the end. It's not the nicest robot, but you can at least teach them some feedback control, some obstacle avoidance, and some things like that. So that kit just became their textbook and they get to keep it.
That is a great resource. So we've talked a little bit also about, as we're engaging students, about we have this issue with hardware and how does it compare, and that, you know, there's some areas where it's fine to go to simulation, or some we really need that that physical experience, and so you can either do it with a buddy system or sending the kits. So those are fabulous ideas. The last area I wanted to touch on, because we had some participants who were curious about this, is how do you see teaching robotics in developing countries where they may have different sets of resources available to them?
So Carlotta just gave a great example of something, well, maybe not being low cost enough for, say, a full class of students in developing countries could be a good start. One thing that out of this crazy pandemic might come out positively is all these simulators, and like the one Karim mentioned, there's a whole ton now of robotic simulators and open source this and that where you can visualize. Of course, it's not the same thing, but it's a great starting point, and maybe some of these tools could then be used in the future to bring robotics education to a wider range of the population, including developing countries.
So I want to bring up a question in the chat here, is because this talks about giving, kind of what we're leading into is access for robotics education for everyone. And so the question is asking about students of diversity backgrounds. How do you support them? What do you feel is your role in doing that? And do you feel your role is any different being a woman or not? So how do you support students of diversity backgrounds is kind of what they're getting at there.
So I'll take this one. I know I keep talking about my freshman class, but it's because that's really what builds their college experience, and that's where you lose them. Either they abandon engineering and head off to the races, or you keep them there. So I absolutely feel it is my responsibility to make sure that first experience in engineering design, in robotics, all of that is a positive one. Some things I do in classes, I actually talk about diversity. So when we talk about the design process, I actually show the videos from YouTube of the woman who has to wear the white mask because the AI doesn't recognize her face, and of the man who tries to use the soap dispenser, but because they use skin color to make the soap drop, he has to put a white paper towel to get the soap. So I talk about that in class, and then I explain that no, they don't pick their own team so that they're on teams with their friends. I pick teams and I put them together by skill set and by experience. And I also make sure that normally, if possible, I don't put women alone. I'm in a primarily engineering school, so our women have a lot of interesting experiences when they're the only woman on a team, like being asked to take the notes and type up the paper. So I give conversations about, no, we don't do that. Everyone on the team is a leader. We alternate the roles on a weekly or bi-weekly basis. Everyone's opinion is important. Everyone has a voice on the team. And I foster that in the way that I interact with them, and I'm a professional, and that I expect them to do the same with all of their peers. So I think it's extremely important, especially as freshmen, to have those conversations so that by the time they're seniors and on their senior design team, it's not an issue anymore.
Mm-hmm.
Yeah, I think everything Carlotta said was great. I think I mostly teach seniors, so I think at that point it's still important, but they're usually already there pretty firmly. But one thing I always do in the first lecture of my classes, I just generally make a statement that I will not tolerate any bad behavior, or if I see anything, it's like inexcusable and whatever. And I generally try to add as many things to just sort of encourage people to feel open and safe in this course. So I even say things like, if you have kids or siblings, feel free to bring them, which I have now had a number of 5-year-olds in my class. So I can now say I teach a wide range of students. So I think just being open and letting people know that you are sort of on their side and an advocate and that you care, I think is one of the most important pieces.
I know sometimes in our position, it is not only helpful to model, but to also be transparent and talk about, these issues in the classroom. So what suggestions do you have for someone who may be frankly scared to do that, right? Not sure how that conversation might go, or how it, how best to frame it. So how would you suggest someone, what would you suggest to someone who's thinking about talking about these issues or exposing these issues to their students for it to be a positive thing?
I was going to say that these conversations were not always comfortable for me at the beginning, but I knew it was important that if I was going to develop the professionals that they needed to be by the time they graduated, I had to just suck it up, buttercup, and figure out how to do it. So one thing that I do in class is I'm like an actress because I am really shy and an introvert at heart. So it's like acting and singing. But I have to correct them when they keep calling me miss, and I have to tell them the correct way to address me in an email. And I have to have conversations about how they're treating the international students or the women or things like that, because when they go to work, they're going to get fired. So I got to get them straightened out while they're in college. So that made it a little bit more comfortable for me. And then once you develop the reputation that they know you're going to do it, they straighten up and fly right real quick.
That's good to put it in that context of, one day you're going to be in the real world and the consequences there are, you may not believe it, but they're much higher than here in college. So we want you to get it right before the stakes are that high. That's good. All right. We're almost done with our time. It's been a wonderful discussion. And so I want to spend the last bit looking forward to the future. So what major challenges do you see looking forward, and where would you like to see robotics education work research head?
Can I start this with a very optimistic view? Because I see more opportunities than challenges. I mean, what I see is actually a lot of new tools becoming available. This experience with remote teaching was not expected, was not planned, but actually we learned a lot. Also from this, we had to adapt rapidly, so we had to change our way of teaching. We had to experiment some other ways, some other tools. I think we can see it as a super experiment, and we can learn a lot from it. And again, all these technological tools available today are opportunities for the future. In robotics, especially, I remember that in my first years, I had a lot of troubles in finding the right materials. I had to basically produce everything by myself. But now there are textbooks, of course, but there are also other resources for teaching robotics, from simulators to, the many tools that have been mentioned already today. The kits, a robotic kit was really a dream for me in the beginning, and now they are available. So I see a lot of potential for robotics and for robotics education in the future, I must say.
I think I really like that comment. So yeah. I think the current situations forced us to get out of our comfort zone. And that allowed us to also learn new things. And these improve somehow our teaching in robotics, because we have to be now creative. And once we are back, hopefully everything is resolved in the near future, I think we are going to learn from that. And we are going to start doing flipping of the classroom, more active learning, all these two-body system in the lab. So I think everything that we have learned because of the current situation, if we want to see it as a positive, it has taken out of our comfort zone. So, and that leads us to the learning curve that we want.
Yeah, I'm excited to see like what we will take from the situation we're in, you know, if we're back face to face and, you know, those kind of as we used to know it, you know, there's been a lot of positive things I've seen that I'm like, I really want to bring this forward. Just even in, I know in my classes, I often teach large classes, and I know if I was a student in that class, I would not ask a question because I have to ask a question in front of 99 other people. That's not going to happen, but I might have a question. But when I give them the chat, when they can do it and they you know, they don't have to stand up in front of everyone really and ask, I get a lot more engagement. And so that's one of the things I'm like, this would be fabulous to bring forward. I don't want to leave that behind. It was not something I ever would have tried, but I was forced to do it. And it's been really positive. So I love that perspective of looking at, can we take from this unexpected situation that's really positive to pull forward and improve our teaching, regardless of what mode we're teaching in.
So Shauna, I wanted to share, I hope somebody's putting a repository of all this stuff somewhere so that it's easily accessible lately. Because one thing I would say is that imitation is the highest form of flattery. And when I first started teaching robotics, I knew I did not want it to be like the robotics class I had as an undergraduate because I wanted the students to touch the robot, but I had no idea where to start. And so I basically just Googled roboticsclasses.edu and I was just stealing stuff from any resources I could find online. Like I took some stuff from I think Holly Yanko and from Maya Matarik. And now I have a whole YouTube channel of all my robotics lectures and stuff because I got to pay it forward from all that stealing I was doing. But I think one of my challenges is getting my undergraduate students ready for graduate school because they're at a school where we don't have a PhD program. So one of my challenges is elevating what I teach them up to a level to create an advanced robotics class, because my intro to robotics class is also normally in the senior year. But if they can have a follow-on course to get them ready for graduate school, because when our students come back, I'll ask them, do you feel like I prepared you? And they'll go, maybe some, you know, there's no RAS or anything like that. So my challenge for robotics education is how to get a higher level course at the undergraduate level for those who want to go on to PhD or even master's work in robotics.
And you specifically have the context where they don't have a graduate program attached where you could just say, go take the grad class, right? That doesn't exist for your students. So how can you bring that, the benefits of that in, right? In the kind of institution that you have. There are a lot of institutions like that where you have students that would be fabulous in grad school, but don't get to try it, right? And so how can you get that for them? I love that topic. What other areas do you see, would you love to see robotics education go? And while they're thinking, I just want to remind you, if you have a question, to place it in the chat. If you put host and presenter, then we'll all see it. We would love to hear. We have a few minutes that we can field a couple more questions. So we'd love to hear from you.
Yes, adding on to the challenges, as robotics becomes more popular and the courses have more and more students, one of the challenges, and this is true for other areas, but also for this one in particular, is how do we keep the content personalized and engaging, and we can really address students when we have 400 students in the class. And so how can some of these things like really physical kits and all of that scale to broader um, student audience, it might become a challenge, and I honestly don't know the best way to address it. But it becomes also when we talked about the different backgrounds and online resources, because now students can come prepared to a class, way prepared, because they can find resources anywhere, which is great. But then making the courses challenging enough students while keeping, for example, the ones who are not so curious about checking things online and so on. So how can we ensure that the level is okay for everyone, is challenging enough for everyone, when students have more varied backgrounds that come from computer science, engineering, or other areas that are not so technical, and at the time they can have all sorts of resources online and study on their own as well.
Yeah, so that's tricky, scaling but personal at the same time. You know, that would be well, you work in social robotics. Maybe there's some way to do that a little bit. I know I've been talking with a colleague about we have a lot of introductory programming classes, and how fabulous would it be if you had a experienced person alongside you, kind of coaching you as you program, right? Well, that doesn't scale, but what if you had some AI system that was watching what you're doing and making suggestions, or you know, giving you that feedback before you turn the final thing in, or giving you those kind of suggestions of just like coding style that's not necessarily, it'll still compile and run and give you the right answer, but there's a big difference in the levels of code and maintainability. And so thinking about how can we scale and be personal, you know, that's really tricky. But a good problem, I think it's a wonderful problem to have, right? To have the problem that too many people are interested, and that, you know, we have now all kinds of people with all kinds of experiences and backgrounds that we didn't have before, which I think makes the community really rich and really gives us a lot of ideas to draw from and perspectives, which I think will only help our field. But we want to make sure that we are teaching in a way that's continuing to foster that movement, right? All right, so I think we are about out of time. I want to point out that Carlotta put for the resources she was talking about in the chat if you're interested. And I want to say a special thank you to all our panelists for, I know this is the end of the semester, some are on sabbatical, but you took time out of your week to talk with us and to talk together. And I really appreciate it. I know I've learned a lot. We'll have the recording available so that you can revisit it. You can share it with your colleagues. There are a lot of great tips in here. And I also want to thank everyone at RAS for organizing it. And it's been a really great conversation. I was glad to be part of it. So Amy, I think I will send it off back to you.
Okay. Thank you, everybody. And this has been recorded and we will be posting it on the RES website shortly. And thanks to all the panelists. It was great.
Thank you, Shauna, for organizing. It was very good.
Well, thank you for participating.
Okay.